Hi, this is Surya. In this video, we are going to talk about and look into how we can run a Spring AI application using MCP clients and servers and using an internal LLM without exposing your data to the external network. Honestly, Java has already lost the AI race. Spring AI developers have done a very good job in bringing the first version of the Spring AI, keeping things abstracted and making developers' life easier to get it integrated with AI tools and chatbots. Since Java is into the enterprise world and a lot of application might be running in the production system, it might make more sense to have something to do with AI in Java rather than having it with Python or like TypeScript. Would make sense for the developers so that they do not have to overarch their technical skills and then lean towards Python for this matter. So a lot of these chatbots, they run on something called as large language model, which is the transformers, like they call it as GPTs. So these probably might be sitting in the outside world, such as OpenAI or ChatGPT, wherein our application can interact with it like over the internet and get the results back. Alternatively, there are some inference engines that are available with the MIT license, which you could use at your workplace, and also you can change the models of your choice that so that you could update down the line if something comes up and then you want to change it by yourself, and then you can try with different models of your choice. So for that purpose, we will go with the Ollama. So we'll have the Ollama installed first in our local machine, and then we will have to select the model that we would need to use. This thing is something that is just to get started with. Once we have things going, we can always switch the model. What is this model does is it gives the generic answer about how the world was when it got designed or trained. So it might not have enough information about an internal of your workplace. So it only will have general information such as what's the capital of USA. That's where MCP comes in, wherein it provides a context such that it provides a context about your product database or information about it, or the set of resource files that you might expose through S3 or a block storage. So the user can interact, type with the user agent, and then they can get the information out of those resource files that you might have in the block storage. So this protocol is something that is developed by Anthropic, and it's been widely adopted by other companies right now. Say in the previous example, let's say a user types in and then he's trying to get an information about your product table. Hey, what is the maximum price for a drink that you have? We might need an API sort of thing to have that result get back to the user, isn't it? So this API sort of thing is nothing but a tool. Similarly, we can have a different tool for different purpose, say one for inventory, getting the inventory details, one for getting the order details as such. But now you might be wondering, how are these tools called? So that's where MCP shines. The MCP client that we talked about earlier, that has the LLM. That LLM connects to the server to make a handshake, and that's when it determines what are all the tools that are available for the client to use, and then the LLM determines what tool needs to be called or invoked. They call it as callback. So when a user asks a question, the LLM decides, hey, I need to use this tool to get that results back. So that determination is taken care by the LLM itself, so we do not have to specifically say in the code what tool needs to be invoked. First thing first, once the Ollama is installed, you should be able to run this command in your command prompt, and it should show you all the list of available commands wherein you can pull a model from the repository, and then it will be always running on 11.434 by default unless if it is changed. Here I have two models already listed, so we will be using Llama 3.2 for today's demonstration. So in here, if I bring it back to the IntelliJ idea, so I have here the MCP client. Consider just this as a chatbot right now, similar to how you see a ChatGPT or a Google Gemini. So to do that, what we have done is we have created a Spring Web project, and within the web project we all have included the Ollama model dependency, since we will be talking to the Llama 3.2 model that we would need to configure in the properties. So I also have the Swagger dependency in here, and this is something that we might need, the Spring AI bill of materials. Jumping back to the property, as I mentioned before, we will need to specify what model we are using, because with Ollama you can switch between models, like you can use Mistral, Gemma or whatsoever, right? Once that's done, let's get started with the controller. A chat controller is something similar to how a chat window would work like. So this controller is going to return the response back from the Llama 3.2. To start with, we have the chat client in here. The chat client will be automatically wired by the Spring AI, so we do not have to worry about it. Since we have the Ollama dependency, it will automatically try to talk to this Ollama server running on this port, and it gets connected. So on this, if you look here, we are not directly assigning the chat client, but using the chat client builder. The reason for it is because we might introduce a history, something similar to how in the chat GPT you ask for a question, and then later on you do not have to specify the context of the first question in the second question, and so on. And the third question you can just do a follow-up question on top of each other. So that sort of forms a conversation history. And then if you want to do that, like, you might need to wire the advisor here. So for this demonstration, to keep it simple, I haven't done that here. This is the controller that's going to take the input from the user and then spit out the output to the user. You need to pass it in the prompt and then call, and then content is going to return the string back to the user. So let's see it running. So let me start this. So once I start that, so this is the endpoint that we have exposed. So let me click on execute, and it's spinning. So it's trying to reach out to the model, and now it's gonna spit out the response here. Okay, so the capital of United States is Washington DC. Now we have seen that. Let's jump into a real world scenario wherein we would be running a production application. Consider here the fridge inventory core as a production application similar to the one that you might be running. We got some controllers here. We got products, orders and inventory. You got the controller, data and the service, and behind the scenes it's getting connected to Postgres database wherein it has few rows in it. Say like milk, eggs, cheese, chicken. Those are all the products that we have right now in the fridge. See, we already have these endpoints exposed as in the form of controller, which we probably might be using through our application in the UI or from somewhere else. Now we would need to use these endpoints as part of our tools. Rather than writing the tools into the core, the better way to do it is like to have an MCP server separately, wherein the tools are living in there. So to do that, we first need to create a project, which I have already placed it here. So similar to the previous example that we saw, we would need the Spring bill of materials in here. If you look here, I have used the MCP starter webflux. If you see here, like, this is the main thing, MCP server webflux, and that's pretty much it. I do not have anything else in this regard, right? So with respect to the properties, I probably will have to specify the MCP server name. So here I am saying that that's it. It's an inventory server. In the products, I have the set of tools. For this demonstration, I have get all products, add product tool, wherein this is going to give me all the products in the text format, right? So with respect to this tool, it's similar to our REST endpoint, but that it is annotated with something called as tool. It has we will have to provide it a name and a description in English, so that the GPT will try to understand which one it needs to invoke. So once we have all our tools specified, we will just have to specify a bean of those tools, as in like the tool callback. So these are all the set of tools that we are saying we might expose. Say if we have multiple services, we can do this as a list. If you see here, like, it's an array of objects, so you can pass in, like, multiple items in here. And then here is the product service that we have. So I just have the product service for the time being, like for this demonstration. So I have this. So once I expose it, I think I have already exposed it. So if you look here, this is the Postman version. There is something called as MCP that shows up. I think that's part of the latest release wherein you could use. And then here to check see if it is working properly, this is the default endpoint that establishes the connection, and then there is the message endpoint as well. For the time being, if you look at it, like we have left it to it as default since we haven't specified anything around here. Now let's go back to the Postman and then hit connect. And once we get hit connect, so it's gonna list the tools in here, and then we can add a product, or like we can get all the tools, right? So it's going to spit me out this. So this is the information that is gonna be read by the LLM client, and then it will figure it out which tool to use based on it. Say for example, if we have multiple tools listed down here, get all inventories, get all orders, it will when a question is asked, the LLM will be able to, LLM is smart enough to determine which tool to use to answer that particular question. So this is pretty much about the service. Now we will have to run back to the client to get this thing connected. To do that, what we will do is, like, first thing first, we will go to the POM. We will enable this stuff because this is what is gonna bring the MCP client back, and the rest of it is what we had earlier. And then I'm going to go to application client and I'm gonna expose this. So this is nothing but the Sync MCP tool callback provider. So this is what is going to get connected with the callbacks, tool callbacks. So we will have two things here. This is the MCP Sync client. The MCP Sync client is something that we will use on the chat. Okay, so this is so we will have to create the bean of this type, and then we will wire it in the chat. So here, let me uncomment this. So similar to our previous AI chat controller, here we have this chat client, and then here we have the Sync MCP tool callback provider, the bean that we created down here, right? And then within this chat prompt, we will have to pass in this tools callback. So this is going to give you the list of tools. So what ends up happening is, like, when the client gets connected to the server is going to provide the schema definition and all those things, right? So let's turn this as well. So this is going to list those information just in case if we need it, right? So that's going to list those information. So about like what the server has to offer, right? Now let's double check on the properties. Okay, so on the property side, we will have to enable this endpoint. We do not have to touch any of those default properties. Probably we can have this enabled as well. Tool callbacks, yeah, we are gonna use the tool callback, and this is going to be the server where the MCP server is running, right? So what's going to happen is the client is going to call the MCP server. The client is going to call the MCP server, and the MCP server in turn would call the fridge core. Not sure if I showed this to you. Let me go back to the product service. And then if you see here, we are just using a REST client, similar to how a client would invoke a service, right? So that's what's happening within the MCP server's tool, right? That's pretty much it. Let's I think let me restart the MCP client again. Okay, now you see here, like it shows the tool name, the description, and the other and the input schema that it is pre-training to, right? So that's pretty much it. So since it has started, let's go to our console. Now I have to flip it back to the chat controller, and then let's MCP chat controller. That's our controller. Now if I ask for like what are all the products that are below $3? If you look here right now, since we have injected this context, it is written in milk, eggs, lettuce, and cabbage. So ideally, what has happened is the product serve. So the MCP client has chat MCP client has this one has invoked. So this is the controller endpoint that we call. This is in turn has called the product service, which is in turn called the get product details, and then it's returning the response as such. And then it has, on top of that, it has also added the filter, but it could be a different tool. So this way we can build a simple AI agent for the specific product purpose. Say if we want to achieve the same on the inventory and on the orders, as we see here on our production application here, for example, inventory controller, then we will have to write a different set of tools for the inventory and for the orders. So that way we can interact with it. This is how we can inject a context into the LLM. I hope at least this would have given you a basic understanding and an end-to-end working of the LLMs and the Spring Boot client and server getting connected to your application. This would just be a starting point. On top of this, we might need to still make more agents and like more tools to kind of make it an agentic AI. That probably might be down the line. But like MCP is relatively new, and the Spring AI just has released its first first version, a release version. I have added a text version of this video in the description box below. See you in the next one.